Let's take a look at how to solve an absolute value equation. So if you remember back from past math classes, an absolute value is defined as the distance from zero on a number line. So for any non-zero absolute value, we're going to have two solutions with that absolute value. So if we're thinking about on a number line, right, here's zero. What the word absolute value of x equals a asks us is for what values of x is there an absolute value of a? And the solutions are going to be a and the opposite of a. So let's think of an exact question. Let's say, what is the absolute value of x equals 5? So we're thinking about how many locations is the distance from 0, 5 on the number line. So we could go 5 in the positive direction, but we want to remember that we could also go 5 in the negative direction. Both are a distance of 5 away from 0. So x could equal 5, or x could equal the opposite of 5, negative 5. Okay. So when we look at this, that's what we're looking at with our number version of this. Okay. So when we look at this algebraically, which is how we're going to be solving it, we want to think about how do we write an equation. The absolute value of x equals a means we're going to set x equal to a or x equal to negative a. And this is true only for when a is greater than or equal to 0. When a is 0, well, when a is less than 0, we get something else happening. And actually, when a is equal to 0, we get something else happening as well. So we're going to take away that equal sign for now. Okay. So let's look at how we actually solve one of these. So that was just kind of a brief reminder of what absolute values are, which we've taken a look at before. So I have some steps here, and we're going to follow through with these steps as we solve. So step 1 is going to be isolate the absolute value, or the expression with the absolute value if needed. So what I mean by that is if we look at these absolute value bars, we want to make sure that the only thing on that side of the equation is whatever is inside the absolute value, right? Nothing adding, subtracting, multiplying, dividing outside. So we're good here. So once we have that, we can split into two cases. So we can take a look at case 1. That's our x equals a, or in this case, whatever is inside of the absolute value equals a. So we're going to have x plus 4 equals 10. Or case 2, which is our opposite case. The expression inside the absolute value equals the opposite, negative 10. And we want to solve these two cases. Okay, so that's step 3. So for the first one, I'm going to subtract 4 from both sides, and we're going to get x equals 6. For the second one, I'm going to, again, subtract 4 from both sides, but this time we're going to get x equals 14. Oops, negative 14. Negative 14. So because we have two solutions, we're going to write them in set notation so that it's really easy to find our solutions. So for the final answer, we're going to write set notation negative 14 comma 6. And it's just standard notation to start with your smaller answer first and then go to the bigger one. So let's solve a couple more of these. So number 2, step 1, isolate the expression. So if I'm looking at my absolute value, it's not isolated. We're subtracting a 6 outside. So I need to get rid of that first. So I'm going to add 6 to both sides. And we're going to be left with the absolute value of 2x plus 5 equals 23. Okay? It isn't until I reach this point right here that I can split into my two separate cases. The reason being, I need to make sure that this number is greater than 0, because if it's not, something special happens, which we'll take a look at in another video. So now I can split into my case 1 and case 2. So case 1 is just my x equals a case. So 2x plus 5 equals 23. Case 2 is our opposite case. 2x plus 5 equals the opposite of 23, which is negative 23. and we can go ahead and solve. So subtracting 5, we get that 2x equals 18. Divide both sides by 2, x equals 9. And then case 2, subtract 5 from both sides. Oops, got some zooming issues there. Subtract 5 from both sides. 2x equals, and then we're going to have negative 28. Divide both sides by 2, and we get that x equals negative 14. So we're going to go ahead and write both of these solutions in set notation so that they're in the same location and are easy to find. Let's do 2 more examples before we move on to special cases. All right, so we're going to isolate our absolute values first, right? So everything inside those absolute value bars needs to be alone first. So we need to get rid of this plus 7 and the 2, negative 2 that's multiplying outside. So first we're going to subtract the 7 from both sides. We're going to get negative 18 on that right-hand side. So as it is now, you want to look here, we have a negative value. So we're running into kind of an issue where we should be looking at that going, I thought that we said that that had to be greater than 0. Well, it's not yet. But that's okay because we're not done isolating the absolute value. So we're not sure that we really have a problem yet because I still have to divide both sides by this negative 2. Make sure that you're not dropping your absolute value bars yet. We're not taking the 2 cases that the absolute value asks us to do, so we still have to have that there. All right, well now we're okay. We have a positive 9 there, so we're all right. Now we can take our 2 cases. So x plus 5 equals 9, or x plus 5 equals the opposite, negative 9. All right, so we're going to solve these real quick, subtracting 5 from both sides to get x equals 4. And in the second case, subtracting 5 from both sides to get x equals negative 14. We're really enjoying that negative 14. That's just a coincidence. You're not always going to get a negative 14 in your answer. All right, so we have negative 14 and 4 as our 2 solutions to this absolute value. One more, and then we'll call it a day for solving absolute values until we start special cases in another video. Okay, so we have our absolute value in the numerator of this fraction. So we need to isolate this. So just like when we were solving equations, we kind of need to treat the fraction as a quantity until we get rid of everything else. So by that, I mean we need to deal with this plus 3 first. So we're going to go ahead and subtract 3 from both sides to start. We're going to get the absolute value of x minus 7, all divided by 2, equals 8. Okay, now before we can deal with the absolute value in the numerator, we need to get rid of this denominator. So that's dividing by 2, so we're going to do the opposite and multiply both sides by 2. We have the absolute value of x minus 7 equals 16. Okay, so don't get rid of your absolute value bars at any point up until now because we still need them. We still haven't taken the 2 cases. That's what those are asking us to do. So now we can take our 2 cases and drop our absolute value bars. X minus 7 equals 16 and x minus 7 equals negative 16. Okay, and solve. So adding 7 to both sides, we get that x equals 23. And then second case, adding 7 to both sides, we get x equals negative 9. Writing our 2 solutions in set notation so they're easy to find. So really the key thing that I want to point out on all of these problems is that it's very important to make sure that you are isolating your absolute value before taking your 2 cases, because we really need to check what that number is on the right-hand side. We need to know, is it positive, 0, or negative? And in the next video, we're going to see where that comes into play a little bit more.